6 operators are used to compare values in Python. These operators work on scalar arguments, such as floating point numbers and integers, and also work on NumPy arrays in pandas data frames in series. The 6 comparison operators can be combined and modified using 3 logical operators, and, or, and not. These only work on scalar Boolean values, plain true or false, and do not work on Boolean arrays, data frames, or series. In a later lesson, we will examine alternative methods to achieve the same operations on arrays of Boolean values. Start by opening Lesson 14. We will use 3 random values to examine the comparison operators. This cell is pre-populated with a command that creates an instance of a random state using np.random.randomState with the input 2000-0101. This is a random number generator that is seeded, and so will always produce the same values. We use methods of the random state to construct the random values so that these will be the same in your notebook as they are in mine. X equals rs.sample produces a uniform. Y equals rs.standardNormal produces a standard normal. Z equals rs.randint 1, 11 produces a uniformly distributed random integer over the values 1 to 10 inclusive. Run the cell and look at the Variable Explorer by clicking on its icon at the top of the window. We see the 3 variables along with their values. The 6 comparison operators are less than or equal to, not equal to, greater than or equal to, and greater than. When used on scalar inputs, these produce scalar Boolean outputs, either true or false. These Boolean values can be combined and modified using the 3 logical operators, and, or, and not. The AND operator returns true when both inputs are true. The OR operator returns true if at least one of the inputs is true. The NOT operator returns true if its input is false, and false if its input is true. It is important to remember that these 3 logical operators can only be used on scalar Boolean values and not on arrays of Boolean values. The first problem asks us to check if each random variable is above the mean of its distribution. We can use f strings to show the value. Inside the f string, we include the expression surrounded by braces, x greater than 0.5, which is the mean of a uniform. The other 2 print statements are identical, except that we use 0 for the normal and 5.5 for the uniform integer. Running this cell shows that the first is false and the other 2 are true. The next problem asks us to check other properties of z. First, we use double equal to check for equality against 7. Running this cell, we see this is false. We then use exclamation equal to check if it is not 5, which is true. Finally, we can check if z is greater than or equal to 9. Running this cell shows this is false. It is simple to check if z is greater than or equal to 2. It is also easy to check if z is less than 8. The best practice when constructing compound statements is to use parentheses to separate comparison operators from logical operators. This ensures that the comparisons are made in the correct order. It also simplifies the mental task of verifying code correctness. We combine these using AND. I strongly recommend parentheses for clarity in compound logical operations. Parentheses clearly establish that we want to evaluate the comparisons before combining the result. Running this cell tells us that z is not in this range. We can then construct the complement using z less than 2 or z greater than or equal to 8. Running this cell shows that it is true. We should recognize that the previous compound statement is the negation of the first, and so we can copy the first statement, surround it with parentheses, and then use the logical operator not. Running this cell also returns true. This is not surprising, since the statement has the same truth table as the previous statement constructed with OR. Python uses 6 comparison operators to convert scalar values, such as floating point numbers, integers, and strings, to booleans. These operators also operate on NumPy arrays and pandas data frames in series and produce arrays of Boolean values. Scalar Boolean values, true or false, can be combined using AND, OR, and NOT to construct complex logical tests.